Hi, in this video, let's find the angle of intersection between the given polar curves, that is r is equal to a into 1 minus cos theta and r is equal to 2a cos theta. The first half of the procedure will be similar to our previous type of problem, that is angle between the radius vector and the tangent. So you are taking log on both sides. Either you can simultaneously solve this or you can solve separately. Now for the first curve, if I take log r is equal to, and there is a multiplication here, log m into n is log m plus log n. So I have written this. And what is step 2? Differentiate with respect to theta. Log r differentiation is 1 by r and r with respect to theta, and log a is just a constant. Differentiation of this is 0, and log of something means 1 by that something into differentiation of that something. Here we are taking with respect to theta. And if you notice, the left hand side is nothing but your cot phi. Since we have two curves, first curve, let me write it as cot phi 1. Denominator is 1 by 1 minus cos theta. So I'll write this as it is. Numerator 1 differentiation is 0. I'm going to differentiate this. And then minus cos theta differentiation is sin theta. That minus cos theta differentiation is minus sin theta. This minus and one more minus is here. So I have written plus. And I want cos on the right hand side. So what I can do, I can use a half angle formula. Sin 2 theta is 2 sin theta cos theta. But here instead of 2 theta we have theta. So half angle. So 2 sin theta by 2 cos theta by 2. Numerator I have changed it to a half angle formula. Similarly, we have 1 minus cos theta. It is nothing but 2 sin square theta by 2. This is by using the formula. Let me write the formula. You might have studied this. Sin 2 theta is equal to 2 sin theta cos theta. Okay, let me write the box like this. Okay, and what is the other formula? Let me correct this. I have written both the formulas. Sin 2 theta is 2 sin theta cos theta. So in the place of 2 theta we have theta. So here theta by 2 theta by 2. Similarly, 1 minus cos theta is 2 sin square theta by 2. In case if we have 1 plus cos theta, this we may use it in some other problem. This will be 2 cos square theta by 2. So if it is 1 plus. So here it is 1 minus. No issues. I am cancelling 1 sin theta by 2. Leftover is 2 also I am cancelling. Cos theta by 2 by sin theta by 2, which is nothing but cot theta by 2. And I am comparing the place of phi 1. I have theta by 2, which implies phi 1 is theta by 2. We are done with first angle. And we have to similarly find the second angle phi 2. And the modulus of phi 1 minus phi 2 will give you the angle. Now see the second curve, r is equal to 2a cos theta. I am taking log on both sides. And on the right hand side we have multiplication. Hence log r is nothing but log of 2a plus log of cos theta. And what we will do, we will differentiate with respect to theta. The procedure is the same. Differentiate with respect to theta. Log r differentiation is 1 by r dr by d theta. Log 2a is just a constant, so this will become 0. And 1 by cos theta differentiation in the numerator, which is nothing but minus sin theta. Left hand side, as per formula, it is cot phi. Already we have written 1 phi, 1, right? So for the second curve, let me write phi 2 to avoid confusion. And we have minus tan theta. Remember in the last video I have mentioned about this rule. because right hand side I want in terms of cot, and I told you if minus is there I will write plus. So cot pi by 2 plus theta. Why? If here minus is there I will write plus here. Why? Because this is pi by 2. Pi by 2 plus theta means it will fall in this quadrant. Here only sign is positive, and hence here we have negative. We have written cot pi by 2 plus theta. Left hand side what we have? Cot phi 2. When we compare this, phi 2 is nothing but pi by 2 plus theta. Already we have calculated phi 1 as theta by 2, which implies modulus of phi 1 minus phi 2. Always when we find the angle of intersection, we will use the modulus value. So if you write phi 2 minus phi 1 or phi 1 minus phi 2, the answer will be the same. So minus pi by 2 minus theta, and hence if you simplify, we get pi by 2 plus theta by 2, because this is half minus 1. So the difference is half, pi by 2 plus theta by 2 if you take it out from the modulus. And here the problem is not over, because we have to find the angle of intersection, means we should know what is theta. How to find theta means they have given in the question, right? R is equal to A into 1 minus cos theta, and R is equal to 2A cos theta. So both are R. If for example if one is R square means we will substitute one in another. Here I can equate A into 1 minus cos theta is 2A cos theta. Both are R. So from the question only we will simplify and find theta. And I am cancelling A on both sides. And you remember for simplification we have used the basic formulas. Same way. Sometimes we will use the formula, I will just simplify. This is a very simple equation because cos theta is on both the sides. If it's different, then we will use the trigonometric formula. And 2 cos theta, I will rewrite this again, 2 cos theta. Which implies if this cos theta goes to the other side, 3 cos theta is 1, cos theta is 1 by 3, which implies theta is equal to cos inverse of 1 by 3. Always we have to find theta and substitute in this equation. Now what will be your final answer? Pi by 2 plus theta by 2, right? In the place of theta by 2, I will substitute cos inverse 1 by 3. Hence your solution, that is the angle of intersection is nothing but pi by 2 plus theta by 2. I will write 1 by 2 into theta is nothing but cos inverse of 1 by 3. Hence we have to solve for theta and substitute here. In case if they ask to prove that 90 degree, by default this phi 1 minus phi 2 will become 90 degree. And in all cases you won't get exactly cot on both sides. Sometimes you won't get it and you have to solve it by using the other trigonometric formulas. See this problem, this is slightly different from the other one. Find the angle of intersection between the curve. R is equal to A theta, this is your curve 1, and R is equal to A by theta, this is your curve 2. Same steps, taking log on both sides. Log R is log A plus log theta, that is log m into n. Since it's in multiplication became plus. And if I differentiate this with respect to theta, 1 by r dr by d theta is log a differentiation is 0, log theta differentiation is 1 by theta. Hence you will get cot phi 1 is equal to 1 by theta for the first curve. Similarly, when you see the second curve, it is log r. Log m by n is log m minus log n. Numerator minus denominator. And if I differentiate with respect to theta, 1 by r dr by d theta, log theta differentiation is 1 by theta. So for the second curve, cot phi 2, which is nothing but minus 1 by theta. Now you can't do anything much about the simplification. I don't have a cot on the right hand side if you see. Hence we have to solve it slightly in a different way. Now if you see this, cot, when I take the inverse, which will become tan on both the sides. You got the tan of first angle and tan of second angle. But still I don't know anything about this theta. So as usual, we will solve for theta. When we solve for theta, your first question is r is equal to a theta and r is equal to a by theta. I am equating because both are r. And when I cancel it, which implies theta square will become 1, which implies theta is plus or minus 1. If you take theta as plus 1 or minus 1, in both the cases, when theta is plus 1, what is tan phi 1? Tan phi 1 is 1 and tan phi 2 is minus 1. So when you multiply these two, tan phi 1 into tan phi 2, this you will get minus 1. So when two slopes, when you multiply these two, tan phi 1 and tan phi 2, 1 into minus 1, which is minus 1, which implies the angle is 90 degree. So hence the point of intersection or the angle of intersection is 90 degree. Same thing happens when theta is minus 1 also. When theta becomes minus 1, when theta is minus 1, tan phi 1 will become minus 1 and tan phi 2 will become minus plus 1. Again, when you multiply tan phi 1 into tan phi 2, you will get same value, that is minus 1, which implies the angle of intersection is 90 degree. Angle of intersection is 90 degree. So always don't think that you can get caught on both the sides and then you can compare the values. Sometimes you will get it by simplifying the right hand side, and in this problem if you see there is no cot here, so you cannot take down the angles or compare the angles directly. Hence in such cases always go for tan of that angle, try to multiply and you may get 90 degree in those cases. There are certain problems where still you won't get 90 degree. You will get tan of first value, tan of second value, find theta and then use tan A minus B formula. For example, if you see this problem, you can pause this and try to solve it on your own. The procedure is the same, and when you see here cot phi 1 we got this, and cot phi 2 again, left hand side it is cot and the right hand side you cannot make it as proper cot. If you see this, automatically we cannot find these explicitly, and as I said we will find tan of the first one and tan of the second one. And we are using tan A minus B formula. Tan A minus B formula, we will use it and then we will find theta as usual by solving this. Once you got the perfect value of theta, in this problem is supposed to be E, and when you substitute it, you will get the answer. So we cannot write this in terms of cot explicitly. In that case, we can use tan of that angle on both the sides and then use tan A minus B, or when you multiply those two, you may get 90 degree also. Thank you.